This tutorial will be the Exam 3 Review Part 2. First of all, you need to know the difference between alkenes, alkanes, and alkynes. Alkanes are single bonds, where alkenes are double, and alkynes are triple. Now, remembering this, carbon always has to have 4 bonds, 100% of the time. So, when we're having alkanes, that means carbon is in the middle, and there's 4 bonds coming off of it. With an alkene being a double bond, we take 2 carbons, and there's 2 lines between them, which means there's 1, 2, 3, 4 more lines, 2 more lines coming off for it to equal 4. And then with the triple bond of alkynes, we have 1, 2, 3 bonds there. That means the other carbons can only have 1 more bond each. But no matter what, carbon always has to have 4 bonds or 4 lines coming off of it. Now for alkenes specifically, they can have a cis or trans arrangement. It's not necessarily all the time, but it does occur. For instance here, notice that the CH3s are going the same direction. They're both going down. If they're both going down or they're both going up, you have a cis arrangement. If you have one going down and one going up, going in opposite sides, you have a trans arrangement. Now, if by chance the double bond is at the very end, for instance, if this is still butene, and it looks like this and it's at the very end, because the hydrogens are the same here, there's no difference. Like here we have a CH3 and an H, that's different. H and H are the same. You're not going to have a cis or trans arrangement. Or if they were both BRs, if it was a BR up here and a BR down here, you're not going to have a cis trans arrangement because they're the same. There is no difference. You need to know the addition reactions of these alkenes. We learned 3. We have hydrogenation, we have halogenation, and we have hydration. Hydrogenation, notice the word hydrogen is directly in the word. That means we're going to take this double bond and we're going to add hydrogens to it. Notice here, it was originally a double bond. Over here, the double bond is gone because the hydrogen reacted with that double bond, and so the double bond broke and they put hydrogens here instead. Same thing is going to happen with a triple bond, except instead of doing it just once, there's 2 additional bonds here. And then once again, here's the double line. On this side, the double line is gone. Halogenation is when you're adding things like bromine, Br2, Cl2, F2, I2, the second to last row. We're going to break that double bond again. And instead of having hydrogens on it like it did over here, we now put chlorines on it. So those chlorines are getting put into the place of that double bond. Then hydration. The hydration one is a little bit trickier. We have the double bond. You can break HOH, water, down into H and OH. So hydrogen is going to go on one side and oxygen is going to go on the other. Notice, if we compare these two, this carbon has a hydrogen and a hydrogen coming off of it in addition to the double bond. This carbon has a CH3 and a hydrogen coming off of it. Well, as a result, the oxygen, the OH group, is always going to go to the one with the most carbons. So if you look over here, here's that carbon. It has a CH3 and a hydrogen. The OH group went with the carbon that has the most carbons coming off of it. The hydrogen goes with the ones with the most hydrogen coming off of it. So over here, the hydrogen comes in first, and then the oxygen comes in afterwards. But that's most important. The OH group always goes with the carbon of the double bond. Remember, we're talking about the carbon with the double bond itself. The carbon that has the most hydrogens coming off of it, or the most carbons coming off it. The OH group always goes with the one with the most OH. OH goes with the carbon with the most carbon coming off of it. I'm sorry, my tongue got twisted as I was talking about it. The OH group goes with the carbon with the most other carbons coming off of it. Know the difference between primary, secondary, and tertiary alcohols and how this affects oxidation. So, if we look at here, you're looking at the carbon in the OH group. So when you're looking and you're trying to determine primary, secondary, or tertiary, you're looking at how many other carbons are coming off of that carbon. So here it is, here it is. So there is no other carbons coming off of it. That's what's making it primary. Secondary, there are 2 carbons coming off of it. That's what's making it secondary. Tertiary is 3. Now this can be in addition to the 1. If you only have 1 other carbon coming off of it, that's the same, that's also a primary. So if there's no carbons, or if there's only 1 carbon, it's considered primary. If there's 2 carbons, it's secondary. If there's 3 carbons coming off of it, it's tertiary. Now, how does this affect oxidation? In order for it to oxidize, it needs to be able to sacrifice hydrogens. For the first oxidation, if it's a primary, it has 2 hydrogens it can sacrifice. So the first hydrogen gets sacrificed and becomes an aldehyde. So notice that you have a double bonded oxygen up here now where the OH was, and you're missing a line to the hydrogen because one of those were sacrificed. You have another hydrogen that you can sacrifice, so that goes away too and it becomes an OH group. Oxidation is increasing the bonds to oxygen. For secondary, you only have 1 hydrogen that you can sacrifice. So therefore, it's going to stop at this step. Since it's a carbon group on either side, it's now a ketone rather than an aldehyde. Notice this hydrogen here is making it an aldehyde. Because there's no other hydrogens here for it to sacrifice, it doesn't go on. And with tertiary, there are no extra hydrogens there to sacrifice. Therefore, there is no oxidation. And then finally, for this tutorial, you're going to need to be able to identify which compounds are soluble and which aren't. Alkanes, alkenes, alkynes are not soluble. You need an oxygen there with the electronegativity to be able to interact with the water to be able to dissolve. Now, alcohols, ethers, aldehydes, and ketones, they all contain oxygen. As a result, that means that they are soluble to a certain degree. Their solubilities are actually fairly similar. Alcohols, if you get more than 4, they're insoluble. The more carbons you have, the less soluble it is. Ethers, 1 to 3, are slightly soluble. If we think about it this way, this is an alcohol. It has an OH group here, whereas an ether has another carbon here. The hydrogen bonding is less here. Hydrogen bonding comes up over and over and over, and even into biology. So because of that oxygen, it does do a little hydrogen bonding, but not a whole lot, which is why it's only slightly. Aldehydes, once again, you have a double bonded oxygen and a hydrogen here. That double bonded oxygen makes it soluble, but only up to 4 carbons. Once you get to 5, it's insoluble. Ketones are the same way. double bonded oxygen, and you have a carbon on either side. Up to 4 it's soluble, but more than that, it's not going to happen. And that is your second review for your Chem 119 Exam 3.